All right. We have some breaking news. We have brand new evidence from NASA that we're going to take a look at and hopefully will help us answer our question this week of what formed this channel, lava or water. So we're going to look at the next couple of slides, some pictures from NASA. And what I want to share here is a photo taken from above the channel. And we have some new information in this as well. So NASA actually managed to land a rover in this area right below our channel. And that rover is going to be in this area, meaning what we are going to be able to get is pictures that are not just from above, but maybe some rock samples or information from down below on the actual surface of Mars. What we noticed when we landed this rover is the actual elevation of this area. So we can use this key down in the bottom and the colors around this picture to help us understand the elevation of this channel and the surrounding land around it. We did this already when we looked a little bit at the surface of Mars on Google Mars. And I can see that anything that is blue is a lower elevation. Anything that is like a yellowish greenish color is kind of about sea level. And then anything that is red means it is a much higher elevation. So I can see that the channel is actually on a higher elevation, and then the elevation dips down, meaning I have a steep hill going down into a very open, low area right next to this crater. And that is where our rover currently is. So at the bottom of the channel. So this image shows that the channel is at a higher elevation, and then you have a steep slope downwards at the end of the channel. The bottom of the channel, I also notice, is very flat. There's not a lot of change in elevation down here, meaning once it goes down that hill, it goes into a nice open flat area. So looking at this a little bit closer, I can see where my channel is, where my rover is, and then NASA actually highlighted the end of the channel where we kind of have this triangle-shaped landform coming out. We're going to look a little bit closer at this triangle-shaped landform, which is going to be my new evidence card E. Now, they put a dotted line around this triangle-shaped landform because it's a little bit hard to tell. If you look really closely, even at this picture, you can see that that land is a little bit smoother, meaning something probably washed away whatever was on the top of that land. So NASA scientists found a triangle-shaped landform at the bottom of the channel on Mars. Based on information gathered from satellites and the Curiosity rover, scientists believe this triangle-shaped landform is made of a different type of rock than the rock around it. Now that we have our rover there, we can actually test the rock, and we can think back to our article about the oldest rock formation, about what processes form each type of rock. If we can figure out what type of rock that is, that will help us understand what was there. Because as you remember, something like sedimentary rock was formed by weathering and erosion, usually due to something like water. Igneous rock was formed by melting and cooling magma and lava, meaning that if I have igneous rock, there's a good chance I have a lava flow that created this channel. If I have sedimentary rock, there's a good chance I have water that created this channel. All I see right now in this card, though, is that actual triangle landform. So before I get my samples back and see what information I can find out about the rock in this area, let's look at some background information about these triangle landforms and what can form them and how we can really help tell the difference. So first I'm going to look at some background information on the triangle-shaped landforms on Earth that are at channels formed by water. I can compare those to the one on Mars and see what's similar and what is different. So I'm going to read this evidence card, and when you go to answer the questions on the next couple of slides, you will also see this card there. If you click on the top right, you can actually view that picture larger. When water flows down a steep slope onto a flat area, the water carries small pieces of rock called sediment. As the water reaches the flat area, it spreads out and deposits the sediment in a triangle-shaped area. Over time, the different pieces of sediments are pressed and cemented together to form a solid rock. The triangle-shaped solid rock that forms over time is called an alluvial fan. And in this picture, you can see that alluvial fan, very much a triangle shape at the bottom of this channel. So we know that that rock in that alluvial fan looks nice and smooth. It is a similar shape as the one on Mars, and we can tell that it was formed by water pressing down on rock over a really long period of time. But let's look at triangle-shaped landforms on Earth at channels formed by lava. Flowing lava can form triangle-shaped landforms at the end of a channel. These landforms are made of rock that forms when the lava cools. The rock that makes up these landforms is often black in color because it is made of cooled lava. So a rock like this would be obsidian. I know a lot of sixth graders in the past have told me that they know of obsidian because of Minecraft. You cool your magma off and then all of a sudden it becomes obsidian. So that is kind of like the rock that we would find at the bottom of a channel formed by lava. And you can still see that it does make a triangle shape at the end of this channel. And once again, it is one type of rock that makes that triangle shape. And this rock is usually going to be black, like cooled off magma. So both of these types of landforms, channels formed by water and channels formed by lava, do have triangle shaped rock at the bottom of their channel or at the very end of it. What we need to do is figure out what this means for us. Can we compare these to the one on Mars, and can we see a clear difference? Do we need to look closer at the rock in this channel and actually see what we find in that rock? And will that help us? So what we want to do next is actually talk about, first off, what do we learn from these two pieces of background information? And then finally, is this helpful information for us? Is this evidence of this triangle-shaped landform at the bottom of the channel on Mars? Is this going to be a useful piece of evidence? Why or why not? Your exit ticket today, after you answer the next two questions, is to tell me what you think. Is the fact that there is a triangle-shaped landform at the end of this channel going to be helpful for us? If it is, tell me why that will be helpful. Why do you think this is a strong piece of evidence? If it's not going to be helpful, or if you don't think it's a strong piece of evidence, tell me what more do you need? Why is this not a strong piece of evidence? And what else would you like to know about this landform? Keep in mind, for right now, there is no right or wrong answer on whether lava or water formed this channel. There is no right or wrong answer on if you think this is a strong piece of evidence or not. It is purely on what you think about this piece of evidence and how you're going to use it, and if you think it is actually helpful for us. Make sure when you're done, you actually submit your Google form so I can get your exit ticket and give you a grade for the day. After that, have a nice night.